Today's going to be 103-2. We're going to solve logarithmic inequalities. And so that's what we're going to be going over today, is solving logarithmic inequalities. Now remember, when we're solving an inequality, we need to find the zeros and any undefined values. So what we need to do is we need to take into consideration the domain of our logarithmic functions as we're trying to graph what our intervals are going to be. So on this first one here, trying to solve this inequality, well, it looks rational, so that's probably a rational inequality, and so maybe I should subtract the 1 on both sides, and so I get 1 over ln x plus 1, and this is minus 1 is less than or equal to 0. So I want to combine this all together because in rational inequalities we want it as one giant big thing, and so finding the common denominator, ln x plus 1 over ln x plus 1. And so I get 1 minus ln x plus 1 over ln x plus 1. That negative distributes, so I get 1 minus ln x minus 1 over ln x plus 1. The 1 and the negative 1 cancel out, and so I get negative ln x over ln x plus 1. And this is less than or equal to 0. So remember, we need to find the undefined values. We need to find my zeros. So to find my zeros, I can say negative ln x equals 0. You just solve what the top is. And so, dividing by the negative, base e to both sides, x is going to equal 1. So that's going to be one of the values. Then my undefined values. The first one is the denominator can't be 0. So if I do ln x plus 1 cannot equal 0, subtract 1 on both sides, ln x cannot equal a negative number. Well, if I do base e to both sides, x cannot equal e to the negative first power, which is x cannot equal 1 over e. We may have to use the calculator to find an approximate for that. So given an approximate, you're going to get about 0.368. So that is the approximate value for that. Then the other thing that we have to look at and consider is the domain. Well, I have a value inside of my ln, and we know that logs, whatever's on the inside of the log, it can't be 0 and it can't be negative. So I have to say x has to be greater than 0. Otherwise, what the rest of the values, negative and 0, are going to be undefined. So on my number line, here's 0 with an open circle. All of this is undefined. Okay, all of that is undefined. If I wanted to go ahead and graph that, I could draw my little x is greater than 0. Then we said that x cannot be 1 over e. So if I say that this is going to be 1 and 2, this value right here, this is going to be 1 over e, and that has an open circle to it because we said it's undefined, right? Undefined means it can't be that value. And then we have a closed circle here because we said x equals 1, and because there's an equal to, I can have my closed circle there. Now I have to test intervals. So the only other value, so the intervals that I have here are going to be something here, and something here. So those are going to be my intervals. I don't test anything over here because we've established that that's undefined. And so you don't have to worry about anything that's undefined. You don't have to worry about it. If I wanted to go ahead and clean that up just a little bit, I have to say that that's open circle and that's closed circle. So what is a value that's here? Right? What's a value that's going to be there? Well, what if I try 1 over e squared? Let's enter that into the calculator. And so 1 over e squared, that's 0.35. So I can use that. So plugging in 1 over e squared into this problem here, I get negative ln of e to the negative 2 over ln of e to the negative 2 plus 1. Is that less than or equal to 0? Well, those cancel out. Those cancel out. So I get negative 2 over negative 2 plus 1. So that gives me 2 over negative 1. That's going to be a negative. So that interval there is going to give me a negative. Then plugging in a value here, I guess maybe looks like I can do 0.5. So if I do negative ln of 0.5 over ln of 0.5 plus 1, negative ln of 0.5 divided by, now make sure you put parentheses around this when you enter that into your calculator, ln of 0.5 plus 1, that's going to be positive. And so I can say that that interval there is going to be positive. And then maybe I can test E. E is a nice value. It's 2.718. So I get negative ln of E over ln E plus 1. Well, those cancel out, so I get negative 1 over 1 plus 1. Well, that's going to be a negative value. And so this is going to be negative. And so my answer is going to be this region, because it's less than 0, and this region here. And so my answer is going to be from 0 all the way to 1 over e, and it's open circle because we said that the 1 over e is the undefined value, and then union bracket from 1 to positive infinity. This next one, now it looks like I see this log squared and it almost looks quadratic. So what if I say u equals log base 2 of x? Well, now it's going to give me u squared is less than 2u plus 3. Now it definitely looks quadratic. And just by checking this out very quickly, I was able to verify that. So if I bring everything to one side, now this is a polynomial, and the way that we do polynomials is we just need to find the zeros, and we put the zeros on the number line to be able to test the intervals. And so factoring this is going to be u minus 3 and u plus 1, and that's less than 0. And so I'm going to get u equals 3 and u equals negative 1. And so now replacing it, log base 2 of x equals 3, and log base 2 of x equals negative 1. If I take base 2 to both sides, I get x equals 2 to the third power, which is 8. Take base 2, turn it into exponential form. We get x equals 2 to the negative 1/2, or 2 to the negative 1, which is 1/2. So now on my number line, I take these values and I have to put them on my number line. I have, we'll say 8 here, and because there's no equal to, right, there's no equal to here, it's open circle. And if I say that this is 0, we'll say that this is 1/2, that's also going to have an open circle added. Now the other thing that we have to consider, my domain. Well, if I have this log base 2 of x, this can't be negative or 0. So x has to be greater than 0. So all of this right here is undefined, and that also gets an open circle there. So now I need to test a value in between it. So we're going to use this statement here to kind of help us, and we'll use our calculator to help verify it. So that looks like log base 2 of x squared minus 2 log base 2x minus 3 is less than 0. So the first value that I'm going to pick, we can say right here, that'll be 0.25. Then I'll pick 2, and then I'll pick 9. So those will be the values that we can go through and test. So because it is log base 2, I could use the change of base formula. Or what if instead of 0.25 I looked at it as 1/4? Or 2 to the negative 2 power. And so if I choose 2 to the negative 2, this is going to give me log base 2 of 2 to the negative 2 squared. Well, those will cancel out, so negative 2 squared is 4. And then minus 2 log base 2 of 2 to the negative 2, those will cancel out. Negative 2 times negative 2 is positive 4. Minus 3, well, that's going to be a positive. I'll use a different color. So that's going to be a positive in that region. And then if I pick 2, because 2 will cancel out really nicely, log base 2 of 2 squared, well, that's just 1, minus 2 log base 2 of 2, those will cancel out, so I get minus 2, minus 3, that's going to be negative. And I know I picked 9, but 9's not going to cancel out really nicely. So maybe what I should do is I should pick the next value. Maybe I should say 16, which is the same as 2 to the 4th. And so plugging that in, I get log base 2 of 2 to the 4th squared. That's 4 squared, which is 16, minus 2 log base 2 of 2 to the 4th. That's going to be minus 8, minus 3. That's going to be positive. So it asks for values that are less than 0, so I know that that's going to be the negative region here. And so my final answer, it's going to be from 1/2 all the way to 8. This last one, it looks like I have x's on both sides, so maybe I should get all the x's to one side. So I'm going to get x log of x plus 1 minus x is greater than or equal to 0. Now that there's an x in common, factor it out. So I'm going to get x times log of x plus 1 minus 1 is greater than or equal to 0. So now using the 0 product property, I can set each one equal to 0. So I can say x equals 0. And I have to say log of x plus 1 minus 1 equals 0. Well, this one's already solved, so that's good. For this one here, I can add 1 to both sides, and so I get log of x plus 1 equals 1. Take base 10 to both sides, turning it into exponential form. Minus 1, I get x equals 9. So now I have my two values. So I can take those values and I can place them on the number line. I have 0 and I have 9. Now the other little thing that I have to examine is my domain. And so my undefined values, this x plus 1, whatever's inside of this log here, I'll highlight it. Whatever's inside of the log here, that has to be greater than 0. So if I subtract 1, x has to be greater than negative 1. So I also have an open circle here. And on top of that, all of this is undefined. So I know that because all of that's undefined, I don't need to test any value there. And because these are equal to, what that means is that I can make these solid circles. So now I need to go through and I need to test the values. So between negative 1 and 0, that's going to give me, I'll just say like negative 0.5. I want to just plug that into my calculator. So negative 0.5 log of negative 0.5 plus 1 minus negative 0.5. Is that greater than or equal to 0? So plugging that into my calculator, negative 0.5 times log of negative 0.5 plus 1, close parentheses, and then it's minus negative 0.5. That's going to give me a positive. So maybe the next value that I can plug in here, maybe I'll try positive 1. So that means 1 times log of 1 plus 1, close parentheses, minus 1. That's going to be a negative. And then plugging in a value like 10. Well, that one might be easy. Negative 0.5 log of, nope, that won't be easy actually. So we'll do 10 times log of 10 plus 1 minus 10. And that's also positive. Okay, so that's positive. All right, so now that I have that, it's asking for values that are greater than or equal to 0, so that's going to be the positive values. So my answer is going to be from negative 1 to 0, union from 9 all the way to positive infinity. So concluding our lesson, what types of concepts were discussed today? Well, we looked at logarithmic inequalities, and the unique thing about this is that we were kind of combining a lot of different concepts together too. We looked at the quadratic type. We had to remember the domain of logarithms. We learned how to solve logarithms yesterday, and so there were instances in which we had to convert it into exponential form to be able to do that. And we had to look at the idea of how all these domains and these values intersect together. There was a lot going on with these lessons. It was a lot of good review. So feedback from you guys. I want to know, what are the similarities to solving a log equation, and are there natural domain restrictions to these logarithmic equations that we've done? So if there's any other questions, if there's any feedback, if anything that you need me to know, go ahead and leave them in the comments.